Greetings and welcome back. So we've got our hero character. He's in the world. We are ready to start using him. As a matter of fact, I'm playing the game right now, so let's go ahead and click stop. And we can see our little player start. So the next thing we're going to do is add some mobility to our player character. So let's go ahead and take our hero character blueprint and open that up. And let's get this nice and big. Now, to do this, we are going to start utilizing some of those axes that we set up earlier in a previous video where we built up our project. I'm going to right-click here in a blank spot in the event graph, and let's grab Move Up. And if you take a look, you'll find Axis Events Move Up. So you want that. You do not want the axis value function. That is just going to report back what the value of the axis is. You want the event. So with that, we will right-click and say Add Movement Input. Boom. Add movement input. Go ahead and connect the two together. Now, we need to define what direction Move Up is going to move our character. Now, this is an important piece of data. I want you to remember it for the rest of the project. X equals forward. So if you think about up being toward the top of the screen, then the x-axis is going to be up. But remember, on our character, his local forward axis is also going to be x. That's going to be super important when we rotate our character. So let's take x and set it to 1 for up. Then let's add another event for move right. And make sure, again, grab the event version. The value version will be highlighted by default. Use your mouse and grab the move right event. Now I'm going to take my add movement input node and let's hit Control-C, Control-V and paste in a copy. We'll just connect that up. Notice we're using the axis value to drive scale. But then take the vector here and change it from x of 1 to y of 1. So instead of 1, 0, 0, it should be 0, 1, 0. Now you're moving in the y-axis. Now with just those 4 nodes, those 2 little tiny graph networks, if we compile and save and go back over to our game and test, we can move the character in all axes. Now I am doing this with the controller, which is why I'm getting nice smooth motion. But I can also use W, A, S, and D as well, and I can move the character around, which is pretty cool. But we can't yet rotate him, and it hasn't even been 3 minutes on the video yet. So let's go ahead and add in rotation as well. Before I do, let's clean these up. Let's make our network look nice and tidy. Let's grab both these and hit C, and we will add a comment for movement. Okay, next, let's do look up. Again, grab the event, and also go ahead and put in look right. Now, before I go any further with this, what we want is to figure out how far the player has actually moved the right-hand joystick. And only if they've moved it more than some percentage, let's say 25% of its full extent. So if they've moved it 25% of the way over, only then do we want to use that data to aim the character. So we're going to put kind of a limiter on there so that it's only going to respond if they've moved the stick a certain amount. Then we want to take the direction that they have moved that stick, convert that into a rotation value, and apply that to our character to make them rotate. And here's how we're going to do that. Let's grab these axis values. Starting with look up, we're going to drag a wire off of axis value and type make vector. So we're going to store this axis value into the x component of a new vector. Now, again, remember, up equals forward. X is also forward. So the x-axis on our character is forward. That's why we're storing look up into x. Take look right and store it into y. We don't care about z because our character isn't going to be using pitch at all. He's not going to aim up and down. He's just rotating around in a circle. So let's start with figuring out how far they just moved the stick. We have the axis values. We know how far the stick has been moved in each axis. Now let's take the return value, which is the new vector we just constructed. Now remember, a vector is a direction and a magnitude. If you get the length of a vector, you know that magnitude. So the return value here is going to be how far they've moved the stick on a 0 to 1 value. So we can test this. We can say, is this vector length greater than some number, let's say 0.25, which would be 25% of the full extent of the joystick? And only if it is, then we want to do some stuff. So let's make a branch, which is kind of like a basic if statement. And we need both of these events to drive into this branch. Remember, you can't go from one node out into two of the same nodes, but you can connect as many events into the same node as you want. So you can go in one direction, not the other. Now, if you want to keep this nice and tidy, something that I really love about Unreal is that you can double click on these wires and create what's called a reroute node, and then just use that reroute to keep everything nice and clean. And yes, if you're from other parts of the world, it might be reroute, but I have a hard time saying that. Okay, so we have now verified that they have moved the stick a certain amount, and so now we're ready to create rotation. Now, earlier I mentioned there's a special class called a controller, and that controller is going to drive our pawn around our world. Now, the controller is going to take in our inputs, it's going to convert those to some values and apply those back to our pawn. As a matter of fact, that's kind of how our add movement input is working as well. So what we're going to do is right-click and say get controller. This could be a player controller, it could be anything. This is the controller that is driving this pawn. We're going to get that controller and then drag a wire off that return value. So now we're talking to that controller and we want to set the control rotation on it. So this is literally going to be setting what direction that controller is going to tell the pawn to face. So notice I didn't say we're going to tell the pawn exactly which way to face. No, we're going to tell the controller what way to face the pawn. Now, what is our rotation going to be? Now, if you're unaware, a rotation in Unreal is actually a struct. A struct is a collection of multiple points of data, which could be of different types. But if you take any struct pin in Blueprint, you can right-click on it, and you can split it apart and see what it's made of. So we have a float value, hence the green color, for pitch, yaw, and roll, which is how we calculate rotation. You can right-click on those, and you can recombine them back to a rotator. So that's going to be your kind of lavender color, pale purple. Now, to figure out what that rotation is going to be, remember, I said the x-axis is forward. If you build things in that way, if you construct your object such that x equals forward, you can utilize some helper functions in Blueprint that will make your life so much easier. Let me show you. So here, we have taken the amount of motion in each of the axes, the vertical and the horizontal axes. We've stored that into a vector. Let's take that vector and watch this. We can say rotation from x vector. So that's literally going to take the x-axis, so the forward axis of that vector, and feed back what that rotation value would be, which is super useful. So now we can take that and plug it right into the new rotation. I don't really like how it's overlapping all these other nodes, so let's just double-click on the wire to create a reroute node, and we'll clean that up a little bit. So it's nice and tidy. If you need to have a kind of a second look at that, I can move the panels around so that you can really see that. Now would be a good time to kind of pause the video if you want to create this on your own. Now, with that done, let's test this out. Actually, before we do that, let's grab everything. Let's hit C and we'll say rotation. There we go. So now we've got that all nicely lined up. If you have kind of some of the OCDs, you can make those nice and aligned, which is great. Let's compile and let's play. And my window came in on the other side of the screen, so let me grab the panel and pull it over here so you can see it. So I can use the left stick and I can move the character around, which is awesome. I can also use the other stick and I can rotate the character, but there is a problem here that you cannot see because you can't see my hands. Let me spell it out for you. So if I take the left-hand stick and I move it to the left, he faces left. That's perfect. If I move it to the right, he faces right. Excellent. Watch what happens if I rotate from right to up. He actually rotates down. The axes coming in on the horizontal axis, so the y-axis on the right stick, are inverted. Now, if we check it on the keyboard, if I hit left, he faces left. If I hit right, he faces right. If I hit up, he faces up. And if I hit down, he faces down. So it's just the axis on the actual gamepad. So let's hit escape. Let's fix this real quick. I'm going to compile and save, and we can close out the hero character. Let's hit Control S so we don't lose any of our work. Let's go back over to Edit and jump into the project settings. And we'll go back over to our inputs. Now, under your axis config down at the bottom, so that's under the advanced area we took a look at. That's where we changed our dead zones. Also, on that note, if you're testing this out with your controller and you're getting any kind of a drift, like it feels like, you know, the joysticks are pulling, you may want to come back in here and adjust your axis configuration, maybe increase your dead zone a little bit. If you set it high to begin with, or you didn't set it, and you're noticing some snapping as you move or rotate, you can maybe pull your dead zone down, so be aware of that. What we're going to do is take the gamepad right Y stick and just check the inverted key for it. So now we flagged it as an inverted axis. So now we close, we hit play again, and if I move the stick left, we're good. Right, we're good. Down, we're good. And up, we're good. So now I can do like circle strafing. He's not animating yet, but that's okay. And we can do our special spin attack, whoa, 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 which is awesome. So we have a character, he's moving around, he can rotate, we've got our mobility in place, and with that we are ready to begin prototyping some actual gameplay. That's going to wrap things up for this video. Thanks a lot for joining me.